Hi, I'm Sylvie Goldman with Confluent, and in this module we're going to talk about K-tables. So in the previous module we talked about event streams, which are series or sequences of key value pairs which are independent of each other. In contrast to that, an update stream is also sequences of key value pairs, but instead of complementary events that each represent a single physical event, an update stream is an update that is applied to a previous value. So in this case, records that come in with the same key are actually updating the value of the previous record with that same key. Here we see two updates, one for the key A and one for the key B. Now, in this update stream, as opposed to the event stream earlier, we do actually only have two final events at the end. One is the latest value of A, and one is the latest value of B. So each incoming event replaces the previous one. So how do we actually define a K-table? It's similar to a KStream, but it is a table. And again, you can use the StreamBuilder. So the StreamBuilder can be used for any number of K-streams, and it can also be used for any number of K-tables in the same application. The difference with the KStream versus the K-table is that we will now be using the builder.table syntax. Now, again, you pass in the name of a topic, and this is the topic that the table will be representing. So unlike a KStream, a K-table can only be subscribed to a single topic at once, and that is the topic that the table really represents. So like we said, a table is representing the latest value of each record. And so unlike a stream, it needs to be storing all of those values somewhere so that it knows what was the latest value at any given time. That means a K-table is going to be backed by a state store. And we'll get into that a little bit in a later module. State store is just a copy of the events that are in the topic that the table is built from that you store on disk so that you can look up and track the latest value of each of the records in that topic. So to build a K-table, you just call builder.table, pass in the topic, and again, pass in a configuration object that just tells Kafka Streams what the type is and how to read the events in that input topic. Now, an interesting thing with the K-table that is different from the KStream is that a K-table, by default, does not forward every change. So in the case of a KStream, every event is its own event, and every event has its own meaning. So we always forward new events. Whereas with the K-table, all we really care about is what is the latest value for this key. For a K-table, it doesn't really matter what each event is that's coming in. All we care about is what is the latest value for that key, for that record. We might buffer the updates for that table in a cache, like you might have with any other key value store. And that cache, only when it gets flushed do these updates get forwarded further down the processor topology. Now, by default, the cache gets flushed every 30 seconds, which is the commit interval. That's something that you, the user, would define. And that just determines how quickly you might see updates from this K-table. You can set it to 0 and see every update, or you can set it to longer and only really get the updates when you need them. And you'll see an example of the K-table in the exercise later. Now, like the KStream, many of the same simple operators apply. You can map values or map entire key value records. Similarly, the map values in the map operator do this. You specify how the value changes or how the entire key value changes, and you can change the type, but you should not be changing the original record itself. And again, there's also a filter operator for K-tables as well, where you can choose to completely drop any updates as they come in. For example, if you think the data is corrupted or invalid for whatever reason, a filter might be an appropriate way to filter out anything that you don't want to cause an update. Now, unlike the KStream, there's actually a special kind of K-table, and this is called a global K-table. To understand the difference between a K-table and a global K-table, you really need to dig down a little deeper into the Kafka Streams architecture. And this really has to do with partitioning. So a topic that we discussed earlier lives on a broker. Now, a topic can be anything that contains events that are related that the user defines. So this might be anything from just a few events to hundreds of thousands or even millions or more events. And that's kind of a lot of data. So what Kafka does is divide these topics up into partitions. A partition is just a logical subset of the data in a topic that is going to be partitioned by key. And that just means that all events with the same key end up in the same partition. So in Kafka Streams, partitions are important because Kafka streams will only deal with one partition at a time. A typical KTable will only see the subset of data for one partition of that topic at a time. And this allows Kafka streams to scale. It gives it that property because you can increase your number of instances, and each one of them will handle only some subset of the total data, as opposed to trying to handle all 1 million records on a single node or on your local laptop. So that's what a KTable does. A global KTable, on the other hand, actually does hold all the records across all partitions. So this can be useful when you want to actually get a view of all the data across the entire topic. Usually this is for data that is smaller in size and something that is static and not updated that frequently. So this might be something like zip codes, country codes, things like that, which don't really change in a continuous way the way that event streams do. So now we'll see an exercise about how to use KTables in Kafka streams.